All right, so in lesson 7, we're talking about the classification of solutions. And it's not so much what is the solution, but what type of solution it's going to be. So for example, let's look at these directions and pay close attention to this because you'll see it again. It says, give a brief explanation as to what kind of solutions you expect the following linear equations to have. Transform the equations into simpler form if necessary. That's going to be our key there. We want to break these down and simplify each side and then look at it from there. So I'm going to start, as always, of rewriting this as addition. And I'm going to rewrite this as 11x. Instead of minus 2x, I'm going to say plus a negative 2x plus 15 equals 8 plus 7 plus 9x. Now, let's look at the left side of the equation, the equal sign here. If I have 11x's and a negative 2x's, if I combine those, I get 9x, and then I have my plus 15 simplified over here. And then over here, I can combine 8 and 7, both constants. And that's 15 plus 9x. Now, let's stop, because what our directions want us to do is to say what kind of solutions we expect and give a brief explanation. So if I look here, I'm going to notice that my coefficients are both 9. My constants are both a positive 15. So if we have the same coefficients and the same constants, what type of solution can we expect? Same coefficients, same constants, there's infinitely many. We don't have to go any further. We already know what the answer is. There are going to be infinitely many solutions. So we transform the equation. The kind of solution we expect is infinitely many, and our explanation, this is good enough for me. Same coefficient, same constant, that means infinitely many solutions. Okay, so that's what our focus is on this lesson. All right, so let's look at this next one. Now we have some distributive property. So what we want to do again is simplify each side of the equal sign, stop, and then see what we know. So I'll rewrite it as 3 times quantity. Instead of saying x minus 14, I'm going to say x plus a negative 14 plus 1 equals negative 4x plus 5. Now, if I look at negative 4x plus 5 here, that's simplified. The right side of our equal sign is simplified. I'm going to use my distributive property over here. This means multiply. So I'm going to go 3 times x, plus sign, 3 times a negative 14. And 3 times a negative 14 is going to be a negative 42. Then we have my plus 1, okay? And still equals this negative 4x plus 5. And then we can combine our constants, a negative 42 plus 1. So think if you go to negative 42 on the number line and you come back 1, you're going to be at a negative 41. So we have 3x plus that equals negative 4x plus 5. So first check out your coefficients. They're different, okay? If your coefficients are different, okay, so different coefficients means unique solution. Now, because our directions just want to know what kind of solution we have, we can stop here. If we were actually trying to come up with the solution and evaluate, we would keep going at this point. We'd say, all right, I can get a solution, let's keep going. Whereas up here, I would stop at this point. Doesn't matter if I keep going, I know what my answer is going to be. Unique solution, once we realize that, then we know to keep going. But again, our directions just want us to tell the kind of solution we expect. All right, well, you probably can figure out the third one, but let's go through it anyway, just so we can practice our explanations and things like that. Okay, so here's my equal sign. I'm going to simplify the left and the right. I need to use the distributive property over here and change some things to addition. So I'm going to rewrite it as negative 3x plus 32. Instead of saying minus 7x, I'm going to say plus a negative 7x equals negative 2 times 5 is going to be a negative 10x, plus sign, negative 2 times 10 is going to be a negative 20. All right, so really on the right side, it's simplified. But on the left side here, I can combine a negative 3x's and a negative 7x's. If I do that, I'm going to get a negative 10x. That takes care of that, and I have my plus 32. And that's going to equal my negative 10x plus a negative 20. So if I pay attention here, I have the same coefficients. Now remember, so does infinitely many and no solution both have same coefficients. So then we have to take a look at our constants, different constants. Okay, so different constants, same coefficients, different constants, that means no solution. So our directions, just basically what kind of solutions are we expecting to find here? Well, I'm expecting there to be no solution. I don't need to keep going because I know that if they have the same coefficients but different constants, there's going to be no solution. Left side's never going to equal the right. Now we want to continue this idea of infinitely many solutions, same coefficient, same constant, different coefficients is unique, same coefficients, different constants. But maybe look at it from the other side. This is what I mean. Okay, it says write two equations that have no solution. Okay, if they have no solution, then we know two things are true. They are the same coefficients. Yeah, I think I spelled that wrong. That's supposed to be an I-E-N-T-S. Sorry, same coefficients. You get the idea, but different constants. And I think it'll something that you guys will eventually memorize, but you don't have to. You can always come back up here. No solution. Same coefficients, different constants. So if we want to write the equation now, excuse me, just write an equation with the same coefficients. Okay, 6. Different constants, plus 2, plus 3. Okay, don't overthink it. You simply have to have the same coefficients and different constants. Is this the only one? No, you can make something else up. 44x plus 1 equals 44x minus 8. I don't know. Okay, same coefficients, different constants. Now, this one says write two equations. I'm not worried if it's write one or two equations, but it wants a unique solution. Only thing you have to do for a unique solution is have different coefficients. Basically, you can just make up anything with different coefficients. So, 4x plus 3, 5x plus 8. Doesn't even matter. In fact, you could write this with your constant being the same because all it matters is different coefficients. Last one. Infinitely many solutions. To have infinitely many solutions, remember we have to have same and same. Same coefficient. Oops. If I can write. Oh, that's really bad, but you get the idea. Same coefficient. Same constant. So just make it up the same. 7x plus 8. 8 plus 7x. And I think you guys get the idea. So again, our focus is on what type of solution we're expecting, and that comes from simplifying and then making sure that you check your coefficients and your constants.
Did I get in there?
Yep, go ahead. It's recording.
Wait, what? It's on? No, whoa.
Whoa.
Oh, geez. Now this is
Hold
going
on.
to be in the video. Hey, guys.
Are you recording?
The snow glows white on the mountain tonight. Not appropriate to be seen.
A
Kingdom of isolation. And it looks like I'm the queen. The wind is howling and there's swirling storm inside. This is math, guys. Knows I tried. Let it go.
Don't let them in.
Sorry, guys. It's not pausing.
Brady. Brady.
No. No, they
No.
no. Let it go.
Let it go.
No, I'm not. I don't know where it is. It's not in the press.